In this video, we will talk about how to simplify radicals with imaginary numbers. So let's say we have the square root of negative 40. How could we simplify this expression? Well, we need to know that the imaginary number I is equal to the square root of negative 1. So we could rewrite the square root of negative 40 as the square root of negative 1 times the square root of positive 40. And remember, we just said that the square root of negative 1 is equal to I. So we could rewrite this as I times the square root of 40. Now, from here, to simplify the square root of 40, we need to do something called prime factorization, and that's where we break down 40 into factors until we're left only with prime numbers. So for example, 40 could be broken down into 20 times 2. 2 is a prime number, so we'll underline that. 20 can further be broken down into 5 times 4. 5 is a prime number, so we'll underline that. And then 4 can further be broken down into 2 times 2. And both of these 2's are prime numbers. So we've performed prime factorization. Now what we need to do is try to identify groups of 2 of the same number. So notice that there's 2 2's right here, which means this can be pulled out and placed in front of the radical as a single 2. And the reason is because if this is 2 times 2 and it's under a radical, what this really is 2 times 2, which is 2 squared. So the square root of 2 squared is just 2. So that's why we can pull that out in front of the radical. But notice that the 5 and the 2 don't have any numbers that they can be paired with, so they have to stay under the radical. So what we get, let's write it over here, 2i times the square root of, we had 5 times 2 that's left under the radical, so that's 10. So this will be our final answer, 2i times the square root of 10. Okay, let's try another one. Let's say we have the square root of negative 27. We could rewrite this as the square root of negative 1 times the square root of positive 27. And remember we said the square root of negative 1 is equal to the imaginary number I. So we can really write this as I times the square root of 27. Now once again, to simplify the square root of 27, we will do prime factorization. So we could say this is equal to 9 times 3. 3 is a prime, so we'll underline that. 9 can be broken down into 3 times 3. And each of these are prime, so we'll underline those. So we just performed prime factorization. Now again, we want to look for 2 of the same number that we can pull out. So notice that we could pull out these 2 3's out front in front of the radical and make it a single 3. And notice that this 3 can't be paired with any other 3, so it has to remain inside the radical. So our final answer we can write as 3i times the square root of 3, because this 3 has to stay under the radical. So this is our final answer. Okay, let's try one more example. Let's say we have the square root of negative 90. How can we simplify this expression? Well, we can start by rewriting it as the square root of negative 1 times the square root of positive 90. And remember, we said the square root of negative 1 can be rewritten as I. So we can write this as I times the square root of 90. Now, once again, we need to perform prime factorization to break down this 90 into smaller factors. So we could say 45 times 2. 2 is a prime, so we'll underline that. 45 can be broken down into 9 times 5. 5 is a prime. And then 9 can be broken down into 3 times 3. These 3's are also primes. So again, we're going to look for numbers or groups of 2 of the same number. So these 3's right here, these can be pulled out in front of the radical and made into a single 3. But this 5 and this 2 have nothing left to pair with, so those have to stay under the radical. So our final answer will be 3i times, remember 5 times 2, that's 10. So we'll have the square root of 10. So this is our final answer.